like you said, it's used a lot in like quantum mechanics, and it's like a really complicated field. And this is just like a quick like layman's term. It just says a fancy name for a complete vector space with an inner product defined by the space. And just like I said, and they put an example of an orthonormal Hilbert space, and that's just perpendicular planes inside of the space. Next one's the Grand Hotel. I'm not going to spend a lot of time since we already had someone do a presentation, but it's just the idea of a hotel with an infinite number of rooms. And it said that the best way is, or if like a big group comes in and all the rooms are filled, you can just move guests from all the odd numbered rooms to like even numbered rooms, and then it'll be open up for like the big group that's coming in. This is probably like his biggest contribution was his 23 problems. He presented them during 1900 at the conference of the International Congress of Mathematics in Paris. And like I said, it's just like 23 like homework problems just for all like the mathematicians of the world. He posed them because he thought they were going to be a huge help in the 21st century. Just two of them, they're probably the most famous of all of the questions that he asked, are the Kepler conjecture and the Riemann hypothesis. And 10 of them have been solved, and many others have been solved. But like the proofs of them are skeptical because like there's a lot of they're like really heavily computer generated, and a lot of mathematicians don't agree with that. And like the biggest question that Hilbert was actually wondering about was the Riemann hypothesis. There's a quote that said if he slept for 100 years and woke up, the first question that he would ask was if the Riemann hypothesis was even solved yet. And this is just like another little quote by him. It says, "Math is a game played according to certain simple rules with meaningless marks on paper." I thought that was funny, just because like how like complicated all of his work was. So this is the Kepler conjecture. I'm pretty sure somebody did a presentation on this one too, but it's the best way to pack with spheres. It was first brought up by Kepler in 1611, and Fuller proposed a proof in 1975, but it was just more face-centered. It didn't really like go with the optimal way to pack. But there's a proof, and it's still not accepted by all mathematicians because it's so heavily computer generated. And this is just a video about what like was learned, or what you would learn by studying the Kepler conjecture. It's like an hour long, so I'm not really gonna show it. So these are his later years. He retired in 1930, married to his second cousin, Kath Jarasch, and they had a son named Franz. They're still living in Göttingen, but it was completely different. Like the Nazis were like in power now, so there were like he was right in the heart of where they were like conquering. So like there, all the Jews, like teachers, students, they were all getting like kicked out of the school or ran out of the country or hanged or everything. He wasn't completely lecturing still, or done lecturing. He was still lecturing a little bit. He lectured a few times for the next 4 years. He was walking back into Göttingen because after the last time he lectured in 1934, he didn't step foot in there again until he was going in 1942, and that's when he broke his arm. Due to the inactivity, he died like the following year, and he became an honored citizen of Königsberg. That's where he grew up. That's where he first graduated college from, and when he prepared his speech, and these were the last 6 letters of the speech, and they're most known because he was very optimistic about math. He didn't believe that anything was unsolvable, and so the last 6 words summed up the way that he looked at math. We must know, and we shall know.